In this video, I'm going to be describing how we can use derivatives to evaluate limits. It's called L'Hopital's rule. First, let's establish some guidelines for how we can use this rule. The first thing is that if you have a rational function and you're trying to evaluate the limit as x approaches a given value of that rational function, the first thing you want to do is try substitution. If that substitution first results in an indeterminate form, meaning you get the result 0 over 0, or in another case, maybe infinity over infinity, and it doesn't matter which is positive or negative, those are examples of an indeterminate form. There are other indeterminate forms. There are lots of indeterminate forms. These are the only two we'll focus on in this video. So if direct substitution gives you that result, then you are allowed to use L'Hopital's rule. And L'Hopital's rule says that if we find the derivative of the numerator and separately find the derivative of the denominator, then we can try and plug in or substitute values and see if it works. So essentially, we're still using substitution. We're just finding derivatives first before we substitute. And be careful. L'Hopital's rule is not saying use the quotient rule, even though that might be what you decide you think you need to do based on the fact that we are dividing two functions. So just because we're dividing two functions, we're not finding the derivative of that quotient. We're trying to evaluate the limit. So we're just deriving separately. We're deriving the top separate from the bottom. Be careful. So let's try it on an example. If I want to find the limit as x approaches 0 of this function, when I try to direct substitute first, the sign of 0 is 0. And if I substitute 0 on the bottom, I get 0 on the bottom. So I get this indeterminate form. I can't divide 0 by 0. So I can use L'Hopital's rule, and I can find the derivative of the top. The derivative of the numerator is cosine of x, and the derivative of 1x is 1. Now, after finding the derivative, I can try and substitute. If it works, then we're done. We evaluate it. If it does not work, then you are allowed to derive again. And you keep deriving until you're allowed to substitute and it works. However, be careful. Don't keep deriving once it works. Otherwise, you'll get the wrong answer. So if I can substitute after deriving once, then I'm good to go. If I substitute 0, I can find the cosine of 0. That's 1. And 1 divided by 1 is 1. So it works. I'm allowed to use L'Hopital's rule. And the limit as x approaches 0 of this function is 1. Let's try it with a different function. This time, evaluating this quotient by plugging 1 in first gives me that indeterminate form. The natural log of 1 is 0, and 5 times 0 is 0. And plugging 1 into the bottom gives me 1 minus 1, which is 0. So I get this indeterminate form, 0 over 0. Let's try and use L'Hopital's rule to evaluate. So I'm going to take the derivative of the numerator. So the derivative of the natural log of x is 1 over x times 5 is 5 over x, although we can just leave it in this form. The derivative of the denominator is just 1. So now I can try and substitute. If I plug 1 in, I get 1 divided by 1, which is 1. And 5 times 1 divided by 1 is 5. So the value of the limit as x approaches 1 of this function is 5. Let's try out one more example. Again, if I try and substitute first, e to the 0 is 1, and 1 minus 1 is 0. And substituting 0 on the bottom also gives me a result of 0. So we get this indeterminate form, 0 over 0. We are allowed to use L'Hopital's rule. Find the derivative of the numerator. The derivative of e to the x is e to the x. The derivative of 3x plus x squared is 3 plus 2x. Now let's try and substitute. If I plug in 0, I get e to the 0, which is 1. And on the bottom, 3 plus 2 times 0 is just 3. So the value is 1/3. In general, if you have a graphing utility or a graphing calculator, always check your answers and make sure you got the right answer. So there's L'Hopital's rule. Again, make sure that direct substitution gives you an indeterminate form result before you use it. Do not overuse it. Only derive until you're allowed to substitute and evaluate.